In this video, we're going to look at the two other centers of triangles we're going to study this year. First, we need to know what a median and altitude are going to be. So first off, a median, it's going to connect any vertex of your triangle to the midpoint of the opposite side. So here, that point on AB, you can see those little tick marks. That point is the midpoint. And so that red segment extending from C over to that point would be a median. So it cuts the opposite side in half and goes from one vertex. So you might guess, well, what if I draw all three medians? Well, that's going to look something kind of like this. So that point D is a point of concurrency. That's some review from last time. It's where those three medians meet. That point D is what we call the centroid. So last time we had circumcenter and incenter. This one is called centroid. So that's where all the medians of a triangle meet. And you might guess, well, is there some kind of property that it has? Yes, it does have a theorem. So this centroid theorem tells us about how each median gets cut up. So it turns out that the centroid cuts each median in a 1-to-2 ratio. That means one part of that median is twice as long as the other. And it's always going to be the part of your median that goes from your vertex to that centroid. The one that goes from centroid to the midpoint is always going to be the shorter one. So you could see here that AD is always going to be double DF, CD will always be double DE, and BD will always be double DG. So that will let us set up equations, find missing lengths, etc. The other point of concurrency has to do with a different segment in a triangle, and that's called an altitude. So an altitude we typically think of as a height, and that's not totally wrong, but more specifically, it's going to go from one vertex and it hits the other side at a right angle. So it may or may not hit a midpoint. It really doesn't matter where it hits that other side, but it just has to hit at a right angle. So that's an altitude there from C hitting AB. Now you could probably guess, what if I draw all three altitudes? That would look something kind of like this. Wherever those three altitudes meet, there's a point of concurrency we call the orthocenter. So that's where your altitudes meet. There is no special property of your orthocenter. There's no real equation or identity. You just have to keep in mind it always goes to the other side at a right angle. We might find that orthocenter by drawing in maybe your altitudes and using slopes and looking at negative reciprocals and solving systems of equations, etc., whenever we're working with points in the XY plane. So that covers all of our centers. We have circumcenter, incenter, centroid, and orthocenter. And that should give you plenty of information to get going on 5.2.